Okay, here we go. All right, 7. Legit, hard problem, not fair, unreasonable. Expect you to know that. It's chemistry. Welcome to the class. Let's enjoy. Oh, did I skip 6?
Yeah.
Well, I should do 6 then first. I'm sorry. 6. 6 is not legitimately hard, although it's a little tricksy.
6 is
And I'm going to actually ask you, sir, Mr. Farrell. You're the one I'm going to ask to do this problem for reasons it'll become obvious to you in just a second. You ready? It says you're using dimensional analysis. Skip that phrase. It shouldn't even be on there. But it'd be good if you did. How many milliliters of table sugar would it take to make 90.0 grams? 90.0 grams? So what am I converting to what?
Milliliters.
Nope. Because I want my answer in milliliters. Grams, milliliters. I know how many grams I have. I want to know how many milliliters that would be. Does that make sense? Yeah. Even though the question is asked backwards, that's the way it's going to be, right? So I start off with what I know, 90 grams of table sugar, and I want to have milliliters when I'm done. Is it okay if I use cursive ML? It's just a thing I do from like the beginning of time. All right. Yes, sir. So I got to turn grams, get rid of grams. How can I get rid of grams? Well, this is unfair. There's nothing there. I don't know anything about table sugar. Do you know anything about table sugar? So how would I expect you to know something about table sugar? Test taking strategy. Come on with it. 1-to-1 ratio. So you assume 1-to-1, hope for the best. Only thing that does that's actually water. If you look though, the previous problem talks about table sugar. And one of the things we talked about in this class is that the density of copper found on the floor, found in a penny, found in the cube I gave you is always the same. So by the way, it's the way they know if something's gold or not, is they weigh it. They put a density, they throw it in a bathtub, and they weigh it, and they figure out what its density is. If its density is gold, it can only be gold. Okay? So if I look at this and go, all right, so it's the same thing as above, correct? Okay, if it's the same thing as above, then what can I do? Use the ratio above. So how many, so I got to put grams at the bottom. How many grams are we going to write down there? 46.1. And it closed up my 4 again, because it's dumb. And then 50.00 milliliters, right?
Can't you just shortcut that as well?
If you have the density, now we need to be careful with density, because the density is grams per milliliter, so here's why I was going to have him do it. Because density is grams per milliliter, what would you have to do to your density? You'd have to flip it over.
Well, I just did density equals 90.
Oh, you could do that way, yeah. You could use the formula. Yeah. Totally. Okay? Although, you'd have to use the density of the previous problem, right?
That's what I did.
That'd be fun. Okay, so you good? Set equals? The biggest problem with that, I don't like using problems from the previous problem, because if I get that one wrong, then I got 2 things wrong, right?
That is true.
Better. But if that's the only way you can see it, just make sure you get the first one right, and you don't care. That'd be beautiful. Okay, get out my calculator. My calculator says 90 times 50 divided by 46.1. And it gives me this garbage dump. 97.613888286. How many significant digits? 3 from this, 3 from that, 4 from that. What do I get to keep? Farrell?
97.6.
Keep 3 digits. 97.6. And the units are, grams cancel it out, sum down to milliliters. Yes, ma'am. Yes. I did. 90 times 50 divided by 46.1. You'd multiply all the top ones and divide by the bottom ones. And divide by each individually. Don't do divided this times this, because that's a problem. The calculator knows the order of operations. All right, 7 is the one I said is legitimately hard, so let's talk 7, shall we? 7. No. Who wants 7? Who's the person that's hunting for an A? Because 7 is probably the blocker. All right, Kerrigan. I'll call on your name. All right, Kerrigan. What is the volume in liters of carbon dioxide gas balloon that has a mass of 100.00 kilograms? The density of carbon dioxide gas is 1.33 times 10 to the negative third grams per every milliliter. You must show one complete conventional analysis to get credit. Cross that off. That should have been there on there. Okay. Although again, some of you would do better with dimensional analysis, just so we're clear.
Wait, we don't have to do dimensional.
Nah. But I really do want you to do it. I mean, I'm not going to make you do it. If you get the right answer, I'm good. You're good. All right, how do we do this?
So
What am I starting with?
100 kilograms.
100 kilograms. Specifically 100.00 kilograms, but that's what you said. Actually, let me get this sort of out of the way and go like this. Ha. Equals, and then I've got 54. No, that's the answer. Cheating. What's my answer going to be in?
It's going to be
It's going to
in liters.
be in liters. That's what it asked for. That's what I better have it in. All right. Now what, sir? What can I turn kilograms into?
You turn into liters.
Yeah, you know how to turn kilograms into liters? Go!
You times it by 1 liter over. You're looking at me like I'm doing.
Because I don't know what you're doing yet. I'm listening, patiently hoping for the best.
You times 1 liter over. It's times 1 liter over 1.83 times 10 to the negative 3.
What?
Negative 3 like x bar.
I understand that. What's the unit that follows that?
Kilograms.
Okay, that would actually work. I didn't expect anybody to do that. But that would actually work. Okay. I'm going to go one. I'm going to take a step in between. I'm going to say that 1 point.
It's an online.
I'm going to say 1 kilogram is 1,000 grams. Because I know how to do that. And now I'm in grams. And then I don't have to do this funky thing you did in your head, theoretically. Because if I look at it, it says 1.83 times 10 to the negative third grams is 1 milliliter. Yeah. So grams have to go on the bottom, so that's a little weird. How do I make that work? It's what you said without the kilograms. This is actually what's on the paper now.
It's
1.83
grams.
1.83 times 10 to the negative third grams is how many milliliters?
Is
1 milliliter.
Wait, no, you want actually? I remember what I did. I was like, wait a minute, a milliliter and a gram are like the same in comparison to a liter and a kilogram.
That's true.
So
I'm not arguing with you. I'm just I want to do it this way because I don't want to lose everybody trying to explain that what you did in your head.
okay,
We move forward.
theoretically.
Okay. All right, theoretically. Okay, by milliliters, I want to be in liters, so I got to fix that up. I'm in milliliters, I want to get to liters.
And then you times
A milliliter on the bottom. What can I put on the top?
a liter.
A liter. I can convert milliliters into liters, and 1 milliliter is.
0.00.
Why are you memorizing? It's on the front page.
0.001.
Okay, I'm in liters now, so I just get out my calculator, multiply all the things on top, divide by everything that's the bottom. So I go 100 times 1,000 times 1 times 0.001 divided by 1 divided by 1.83. Why's your head down? Times 10 to the negative 3. This is the hard problem. Make sure you're with us. I said you're going to have to focus extra hard. Divided by 1 more time. And I get what a lot of people got on their paper, and I would have marked wrong had I had an opportunity to do so. All right? But now we're always going to think significant digits. I want you to tell me, Miss Kelly, significant digits. Where? That's 100.00. That's 5. That's 5. Because that has to be significant because that one is. right? So if that's the case, that's 5. Anything else that might affect my significant digits? This one looks like a measurement, doesn't it? 1.83 times 10 to the third. It's that many grams per milliliter. That's a measurement, right? And it's not perfectly exact, which means this limits us. This is only good to 3. Now again, why don't I use liters to milliliters? Skelly? Why don't I use milliliters? Why didn't this make it 1? It's because these are exact. It's because there's exactly 0.001 liter per every 1 milliliter. That's exactly true. Why? Because we said so. We made it up. That's how we know what a milliliter is. It's 1/1000th of a liter. That's how we know. Okay. Whereas this, clearly somebody got out something and put it in, did your lab that you just did, and measured it out. Okay? All right, which means only good to how many digits, sir? Kerrigan? 3. So I'm going to chop it right here after the 3rd digit. Now it's tempting to write 546, but that wouldn't be right. Why? Well, I got the 546. That's legit.
It's not exact. It has to be 546,000.
I need 100, right? I need 2 more zeros, don't I? Yeah. I need to denote that these aren't legits by making them into zeros. Yes, ma'am. What would be what? What about the 1? Where do you see a 1? Because of? That's exact. So that's exactly true. So that's a billion significant digits. So that doesn't affect me. That's exact. So that's good to a billion significant digits. How do I know that? Because 1 kilogram is exactly that many grams. Exactly. There's no. It's not even a measurement. It's a definition. But this, that's a measurement. Somebody did the lab you did and say that's how many grams per milliliters I have, which means it's only good to 3 digits. This is good to 5. If this has been worth less digits, then that might have limited us as well. Yes, sir.
And so in scientific notation, are you only counting the 1.83 as significant?
Right. Now that, by the way, some people really like scientific notation for the following reason. If I write 2.03, how many digits do I have? 3. If I write 2.030, how many digits do I have? Times 10 to the whatever. 4. Whatever I write down is how many digits you have if you use scientific notation correctly. It's exactly that many digits.
How come when you write, if you were to write it out 0.00183, there would be 5 significant digits?
There we don't. No, it wouldn't be because it'd be 0.00183. These 2 are placeholders, so it'd be 3 digits. Either way you do it, and that has to be true, right? We can't change how accurate a measurement is because we changed how we wrote it on a piece of paper. That's no good. There, are you with us?
Yeah.
Working towards your A? Yeah. You're close. You're close. All right.